this is Mrs. Groves, and today we are going to be talking about section 1.6. We're going to be learning about functions, and we're going to talk about function tables and function rules. And you're asking yourself, what the heck are functions? Well, it's really not that complicated. Functions are graphs. All right. So first, let's make sure you remember what a graph is. Right? So we have a graph here, X and Y, and we're going to spend a lot of time this year talking about lines. So whenever you graph, you always label the X, you always label the Y, and that point there is represented by an ordered pair, X, comma, Y. All right? So, we're going to learn a lot of new vocabulary in this section. The first one is a relation is a set of ordered pairs. And what does that mean? Well, if I have a set of ordered pairs, all right, and we'll just pick some 0, 3, and we have 3, 2, and 1, 2. And those are 3 ordered pairs, and we could plot them on a graph. Okay, but what we're going to learn is that there's special kinds of ordered pairs, special kind of relations. And those are, a function is a special relation that has no repeating x's. Now remember, this is the x, and that's the y. So right here, we have 3 ordered pairs. That's an example of a function. All right. If I were to add a different point, and say I add 3, 4. All right. Now, if I look at my x's, I don't care about my y's. If I look at my x's, then notice here I have repeating x's. So adding this point, 3, 4, makes this not a function. All right, so functions have no repeating x values. Now we're also going to learn a second definition of how to identify a function, and that is if we're given a graph, it has to pass the vertical line test. And we're going to abbreviate that VLT, vertical line test. But we're not going to cover that today. We're going to focus basically on looking at ordered pairs and determine if they're functions or not functions. But before we do that, we're going to learn a bunch of new vocabulary. And so we're going to learn that the domain is the collection of all x values. And the range is the collection of all y values. So a good thing to do is we're going to have a little table over here, because this is all new vocabulary. So if I ask you for the domain, I'm asking you for the x values. If I'm asking you for the range, I'm asking you for the y values. Now in science, and we're not going to use pretty much independent and dependent, the x variable is the independent variable, and the y variable is the dependent variable. So in science, you're going to have an independent variable and you're going to have a dependent variable. Independent x, dependent y. We're also going to learn about function notation and functions, and x is the input and y is the output. We're also going to learn later on that there is special notation. If we are given an x, we're going to learn function notation. F of x, okay, this means y. Right, so these are all, these are all vocabulary for x. These are all vocabulary for y. So now we're going to look at an example. We want to identify the domain and range of a function, and we have an input-output table. So here we have input, output. Well, input is x and output is y. So this is like, remember, you can have an XY table. There is the input, there is the output. Another way is that if we had an equation, y equals 2x plus 1, right? We need to know the values of x. So we have this function machine. We input x, and then we output y. So we're learning all this new terminology. So the question here is identify the domain and range of the function. So the domain, and you should always write domain, x equals, and it's your x values, 0, 2, 4, 6, and 8. And your range is all the y values. Y equals 24, 27, 30, and 33. Notice that I'm not going to repeat the 33 because the range is a list of all possible y values. So do not repeat 33. So what I like to do is to pause the video and try this problem on your own. And so you want to identify the domain and range of the function. So you do it and then start the video back. So you're back. Your answer should look like this. The domain are your x values, 4, 7, 11, and 13. Your range are your y values, 10, 20, 35, and 45. So that was simple. So now we want to identify a function. A function means no repeating x values. So we've got two examples here. And so I'm going to look at this, and here's my x and here's my y. And you notice that, is this a function? No. It's not a function because you have repeating x values. Now, if you have the table and you can circle the 2's, that's great, you're done. But if you have to write it as an explanation and you don't, then you just want to put, you got repeating 2's. Alright, so sometimes you're going to get problems that look like this. And this is called a mapping diagram. And the easiest way to deal with this is to translate that into an XY table. So we look at 4, and it's matched to 1. We look at 8, it's matched to 2. We look at 2, it's matched to 2. And we look at 2, 2 is also matched to 3. So the question is this a function? And the answer is no. I have repeating 2's. So this example right here, I have 2 examples, and this would be the same answer for both. So now I'd like you to pause the video and determine for number 2 and 3, are they functions or not functions? Welcome back. And hopefully you've decided that example 2 was not a function because you had repeating, you circle the 5's, you had repeating x values. All right? And for number 3, that is a function because you have no repeating x values. So your x values here, there are no repeating x values. So that's all you have to say. It's a function because there's no repeating x values. It doesn't matter that you have repeating numbers in y. All right? So now we're off to the next page. And we're going to talk about rules. And you're good algebra students and had good algebra teachers last year. So you might remember y equals mx plus b. And if you don't, all you have to remember is that the rule has to be y equals something. So for this example here, a function may be represented using a rule that relates one variable to another. So we have this verbal rule, and we have the output, which is y. So y is means equals 2 less than the input, which is x. 2 less, so that's going to give me x minus 2. So my rule equation is y equals x minus 2. So now it says fill in the table. So my input is the x, my output is the y. So this is why they say you're going to input the 2, throw it through the function machine. 2 minus 2 is 0. And we output, so we input x, we output y. So you can fill in the rest. 4 minus 2 is 2, that's y. 6 minus 2 is 4, that's y. 8 minus 2 is 6. And 10 minus 2 is 8. So now we're going to talk about, let's make a table for a function. The domain of the function y equals 3x is 0, 1, 2, and 3. So our function that we're dealing with is y equals 3x. And the domain is our x values. So x is 0, 1, 2, and 3. We put these numbers through this function machine, and we're going to get our y values. 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. So these were the domain. And we output the range. So the range is y equals 0, 3, 6, and 9. So our last two problems are going over how to write function rules. And function rules, okay, so just remember the function rule has to be y equals something. So we have our x and our y. So x is the input, y is the output. We want to write a rule. So we're going to look at the relationship between our x and y variables. And you should notice something. You notice that each output is twice or 2 times the corresponding input. So a rule for this function is going to be y equals, and we look at our x values, and if we multiply them all by 2, we're going to get our y values, 2x. Okay, so x is our input, y is our output. 2 times 3 is 6, 5 times 2 is 10, 7 times 2 is 14, 9 times 2 is 18, 11 times 2 is 22. So this is the rule. So now what I want you to do is pause the video, and I want you to look at this example, and I want you to find the rule, and then I want you to identify the domain and the range. So pause the video, do the problem, and I'll come back with the answer. So first let's do domain and range. That's easy. Okay, so here is our input. Our domain is 1, 2, 3, and 4. Our range is our y variables. Y is equal to 1.5, 3, 4.5, and 6. So to find our rule, we know it's going to be y equals. And you could have come up with two answers. If you notice that all of these compare, and notice that I have 1 plus half of 1 gives me 1.5. 2 plus half of 2 is 3. So I could have written the rule as y equals 1.5x or y equals x plus 1/2 x. All right. I hope you have a nice day, and we'll see you the next time.